Hi team, we're about to start section 3.1, quadratic functions or parabolas. A quadratic function is a polynomial that has a highest variable exponent of 2. In its general form, it would look like this, where A, B, and C are constants. So we know it's a quadratic because the highest exponent that we see on a variable is a 2. So let's take a look at some of the important characteristics of a quadratic. The one that is graphed here is a quadratic that's opening up, a parabola. It looks like a bowl. It can also open down like an umbrella. So the first thing that we can do is to determine, here are the characteristics down here, to determine if a quadratic is concave up or concave down is if A is positive, then it's going to open up. That leading coefficient, if it's positive, it opens up. If A, that leading coefficient right here in front of X, if that A is negative, it's going to open down. Remember how to find x-intercepts? We're going to plug in y for 0. And for parabolas, there are 3 possibilities. We can have 2 x-intercepts here and here. We could have 1 intercept if it only crosses the x-axis once. Or it's possible that it doesn't cross any x-intercept. So we can have 2 x-intercepts, 1 x-intercept, or no x-intercepts. For the y-intercept, we plug in x equals 0. This is where the parabola crosses the x-axis. Now, the vertex or maximum or minimum, if we notice our pictures here, it would be the lowest point, so a minimum if it is opening up, or it'd be the highest point or the maximum if it's opening down. So you can visualize if it opens up, you're going to have a bottom point. If it opens down, you're going to have a top point. These points or turning points where it changes directions is called the vertex. So in order to find the vertex, we are going to use the A and the B value to find the x coordinate. Now the vertex, we usually use H and K instead of X and Y, just to say this is representing our vertex. So to find the input or the H coordinate, we take the opposite of the B value and divide it by 2A. And then to find our K value, we plug in that H value into our function, or find the function value of that negative B over 2A. So once you find the input for our vertex, you plug that in and find the output of our vertex. And again, if it's opening up, then that vertex is going to be a minimum. And if it's opening down, that vertex is going to be a maximum. Looking back again at our picture, the axis of symmetry is an imaginary line that splits that parabola in half. That parabola is going to be a mirror image across that axis of symmetry. And notice that axis of symmetry always goes straight through your vertex. It is a vertical line. So to find your axis of symmetry, you're going to have x equals h. Simple enough, right? Axis of symmetry, and you can write yourself a note where h is the input value of your vertex. So axis of symmetry, once you find your vertex, you can always find the axis of symmetry. Just be sure you have the x equals because it is an imaginary line. So it needs to be the equation of a line. Now, also, if we look at the leading coefficient of A, so the larger the absolute value of A, the more narrow the parabola becomes. The smaller that leading coefficient is, the wider the parabola is. So narrow versus wide. Think of it as it being stretched up or squished down. The standard form of a quadratic equation is also called the vertex form, and that's the form where y equals a times x minus h, that quantity squared, plus k, where a, again, is the same leading coefficient, and hk are the coordinates of the vertex. So let's do an example where we're trying to convert it from the general form into the vertex form. Well, in the vertex form, remember this a here is the same as this a here. So we know f of x is going to be 3 times x minus h quantity squared plus k. So now we need the vertex. So here's an example of finding the vertex. The 3 is our a value. The negative 12 is our b value. Well, remember to find the h coordinate of the vertex. We take the opposite b over 2 times a. So that's going to be the opposite of a negative 12 over 2 times 3. So that's going to be a 12 over 6. So we have an input value of 2 for the vertex. So we have a 2. Now we have to find the k. So that means the output value. So we're going to plug in that 2 into our original function. So we get 3 times 2 squared minus 12 times 2 plus 5. 4 times 3 is 12. 12 times 2 is 24 plus 5. I believe that gives us a negative 7. So now that we have the vertex, we can plug that into our vertex form for the h and the k. So that gives us f of x equals 3 is still our leading coefficient. X minus our h, which is 2, quantity squared, plus our k, but our k is a negative 7, so plus a negative 7 is the same thing as minus 7. So notice as we're reading a vertex form of an equation that the x value is the opposite of what we see, and that the y value is the same as what we see. That throws off some people, but it's because of the formula. We're subtracting up here, but then adding that k value. So that's why the inside is the opposite and the outside is the same. Now let's focus on another example where we're graphing a quadratic by finding specific characteristics. So we're given the function f of x equals a negative 3x squared minus 3x minus 1. It's quadratic, so we have an x squared. So we look at our first coefficient, it's negative. If it's negative, that means it's going to go downward, so it's concave down. If you're afraid you're going to forget, just put since a equals negative 3 is negative. Then we want to find the vertex. So again, the negative 3 is our a value. The second negative 3 is our b value. So the h value of our vertex, negative b over 2a. So that's the opposite of the negative 3 over 2 times the a value, which is also negative 3. That gives us a positive 3 over a negative 6, which reduces to a negative 1/2 for our h value. Then for our k value, we're going to plug in that negative 1/2. So we get a negative 3 times a negative 1/2 squared minus 3 times a negative 1/2 minus 1. So let's simplify the k here. We have a negative 3 times a negative 1/2 squared is a positive 1/4. Remember, you have to do your exponents before you multiply. -3 times a -1/2 gives us a +3/2 minus 1. And then starting again, -3 times a +1/4 gives us a -3/4. Plus, I'm going to change that 3/2 to have the same denominator. So that is 6/4. Forgotten how to do that. Multiply top and bottom by the same number to get that 4 in the denominator. And same thing with the -1. We're going to write that as a -4/4. This gives us a -1/4. So we have a vertex of a -1/2 and a -1/4. So for the axis of symmetry, remember that's always the x coordinate of our vertex, which is a -1/2. So we get x equals -1/2. Axis of symmetry, you have to have that entire equation. For our y-intercept, remember our x is 0. We have to find our y. So we're going to plug in 0 for our x. We get -3 times the quantity 0 squared minus 3 times 0 minus 1. So all of that gives us a -1. So we get a y-intercept of 0, -1. So a couple of things before we even look at the x-intercepts. We can plot the points that we know so far. We know the vertex is at -1/2, -1/4. So if we were to zoom this in, -1/2, -1/4, our vertex would be roughly there. And then they also said that we have a y-intercept at 0, -1. The nice thing about the axis of symmetry, let's draw that dotted in red, is if we find any point on one side of the vertex or the axis of symmetry, then we know we're going to have a point the same distance on the other side of the axis of symmetry. So whatever this distance here is of 1/2, we're going to have the same distance here of 1/2. So our parabola is going to go down like this. Now that doesn't seem very big, but that's going to help us in this particular example with E, x-intercepts. Well, again, we know x-intercepts. We're going to have x and a y for 0. So normally we would plug in 0 equals a -3x squared minus 3x minus 1, and we'd have to solve for that. We're going to learn how to solve those quadratic equations in the next section, 3.2. So in the meantime, you can use your calculators like we did in earlier sections. Just put that in the y equals, graph it, see where it hits the zeros. But in this example,
there are no x-intercepts
because our vertex landed below the
axis
and we knew it's opening down. So just by that graph alone, we know there are no x-intercepts, no zeros. And then the last question is intervals of increase and decrease. Again, remember, intervals of increase and decrease are only in terms of x values. Well, I know that this function here is increasing all the way up to that point right there. So that means all x values up into that -1/2 will give me increasing y values. So intervals of increase will be from -∞ to -1/2. And we're going to always use x values for both increase and decrease because it's a function. The y's could repeat, but the x's won't. Okay. So from -∞ all the way to a -1/2, our function is going up left to right. It's always read left to right. Well, then it starts to decrease at that -1/2 going to the right. So we will say decrease from a -1/2 to infinity. So again, from left to right, it's going down everywhere from that -1/2 out towards infinity. It's going to keep going down and down and down and down and down. Now notice when we wrote it in interval notation, the -1/2 is in parentheses for both. At your vertex, which is your max or your min, it is neither increasing nor decreasing, right? It's a turning point. So you do not use a bracket stating that it's still increasing at that value. We'll use parentheses always. So the next one is an example of finding quadratic equation from a given information. And we have two forms. We have the general form and we have the vertex form. But when they're giving you a vertex form or a vertex point, then the vertex form is usually the easiest to use. Y equals A times X minus H quantity squared plus K. So we can plug in our vertex values. Remember, for that H, it's going to be minus a negative. We can change that to plus a positive, but we still have to find the value of that leading coefficient. So notice we have three variables here. We have the Y, we have the A, we have the X. Well, the X and the Y again represents every possible solution to this equation, and solutions are represented as points. Well, guess what? We have a point, 0, -1. We could plug that into the equation and solve for A. So let's plug in -1 for our Y. A. Our X would be 0. Minus a negative is plus a positive. So we have plus 3 squared plus 2. So we get -1 equals 3 squared is 9. So we get 9A plus 2. Subtract 2 from both sides. We get 9A equals -3. And we get A equals a -1/3. Now we have all the pieces of information we need to write our quadratic equation. Y equals a -1/3 X plus 3 quantity squared plus 2. Now let's think about some different concept questions involving quadratics. Let's suppose a swimmer dives off a cliff and their height is represented by a quadratic function S of t, where t is in seconds. Well, if we were to draw that, let's say here's the cliff in green, and we're hoping there's water down here below. If you have a diver up here on top of the cliff and they jump off, that is part of a quadratic function. It's creating a parabola. So when you look at that picture, we can consider the water, the x-axis, that edge of the cliff as our y-axis. And if we were to draw it, it would look something like this. So in question 4, it says, when looking for their maximum height, what point are we looking for? So we can look at the picture. The maximum height would be up here. And what do we call that point? The vertex. So the vertex. And when looking for that maximum height, we look for the vertex. Then it asks which coordinate would answer the question. Well, we're used to it being H and K, but in the context here, T is our input and S represents our height. So S, or the output, would answer our question, because we want to know the height that he's at, not how long it took him to get that high. In question 5, it says, when looking for the height of the cliff, what point do we look for? Well, that's this point here. How tall is that cliff? So think of it in terms of your XY intercept. That's where it's going to meet. So we're looking at the y-intercept, which remember is of the form 0y. And which coordinate would answer that question? The height would be the y value of the y-intercept. The last question, when looking for when they will hit the water, okay, so there's a hint there. When they would hit the water, not where, what point are they looking for? Well, here's the point where it hits the water. What point is that? That would be your x-intercept or t-intercept. Remember, your x-intercept has an x value and your y is 0. Which coordinate would answer that question? Then that would be your x coordinate, or in this case, it's your t, your input value, your t value. And your y value in this scenario is your s value, because that's your height. So sometimes if you're not sure, draw a picture. Even though it doesn't ask you to, draw a picture of the scenario, and then sometimes that can help you figure out what you're actually looking for. So let's do a couple of modeling examples. If a stone is thrown directly upward from a height of 30 feet, so you're up here at 30 feet and somebody throws a stone from 30 feet up, let's say they throw it off a building or something, and it has an initial velocity of 60 feet per second. It says the height of the stone t seconds after it has been thrown is given by this function here. They've given us the function. Even though they're describing 30 feet high, initial velocity of 60 feet, really all that's telling us, oh guys, there's an error here. This equal sign should be a plus. You don't have two equal signs in an equation. That's my bad. So they gave us the equation. So that first sentence just tells us how they came up with that equation. Okay, we're not even going to use that 30 feet or the 60 feet per second right now. So they've given us the equation. Thank you. Determine the time. Okay, so they're wanting to know t, the input, at which the stone reaches its maximum height. So that maximum height, that means we're going to be looking for the vertex, and they want to know the maximum height. So we're wanting to know both coordinates of that vertex. So let's do our vertex formula. So the h coordinate of our vertex, that's the input. That's going to be, again, the opposite of b over 2a. So we have the opposite of 60 over 2 times a negative 16. Now, if we were to keep this in fraction form where it would be exact, it would be, I believe, 15/8. But it does go into an exact decimal of 1.875 because we're talking about time and maximum height. It's usually a lot easier to go in terms of decimals. 1.875, let's see, h is our, oh, wait, okay. I don't want to confuse you guys. This is the h part of the vertex, the hk. So when we're dealing with the height and the time, that would be our t, and they're using h for the height here. So just to clarify, we're looking for the input value of time. So this would be, I believe, in seconds. And then we're going to find the k, or the height, which is the h of the 1.875 seconds. Which, if I put it in my calculator correctly, that is 86.25. And again, set the height, and we're dealing with feet. So you can say the stone reaches its maximum height of 86.25 feet in 1.875 seconds. The next problem, it says a local newspaper's quantity of subscriptions are linearly related to the price. This is represented by the equation Q equals negative 2,500p plus 9,000, where P is the price in dollars. They want to know what price should the newspaper charge for a quarterly subscription to maximize their revenue. Well, this one's interesting because Q just represents the quantity, okay, how many subscriptions they're selling. So revenue is price, if you remember, times quantity. So that means price times the Q, but we want it in terms of only one variable. Well, we have the quantity in terms of the price. So to find that revenue function with respect to price, we're going to multiply price times the quantity function, 2,500p plus 9,000. So I get a negative 2,500p squared plus 900p. And again, we're wanting to maximize this revenue. So we need to find the vertex. And again, our leading coefficient is negative, so it does in fact open down and have a maximum value. So to find the vertex, the input value, again, is still negative B over 2A. So in this case would be a negative 9. Oop, that's a 9,000. Sorry, I dropped a 0 there. Would be 9,000 divided by 2 over 2,500, negative 2,500. And that gives us 1.8. And if the P is in dollars, then it would be $1.80. So the newspaper should charge $1.80 to maximize revenue. They did not ask us what that maximum revenue would be. They just wanted to know what they should charge. Okay? So that's what they mean by asking for the price. What price should the newspaper charge? All right, let me double check since I missed a page on some other sections before. That's it for section 3.1. If you have any questions, don't hesitate to contact me or contact your instructor if you have any questions. Thanks, guys. Talk to you later. Bye.